Welcome to Industrial Problem Solving. My name is Dave Roysum. Many of you probably know of me as an author, consultant, or teacher. Yet, at least half of my work is industrial problem solving. In the past 40 years, I have been in about 1,000 plants practicing this art. I have written 2 books on the subject. I teach a 2-day course in the subject. Here, I would like to present the essentials of industrial problem solving in bite-sized YouTube pieces. I expect you will find that this course is quite unique and uniquely suited to the kind of things that you may be asked to work on. Critical thinking, which is the title of this series, has several aliases including industrial problem solving, troubleshooting, and many others. Each of these aliases has several different usages, depending on whom you ask. In this course, we will focus on the types of problem solving you may need to do on your machinery in your plant. Since I am a web handler, practical examples will include those that you may have on your web machinery. I will also take examples from everyday life to illustrate some of the many tools we have to choose from depending on the problem we are working on. In this course, we will define critical thinking as a 4-step process. Step number 1, define the problem, and that may include an estimate of the cost. Step 2, determine the theory that is most compatible with what you know. Test that theory to see if it can be replicated and is predictive. Step number 3, decide what you should do now that you know how the thing works. This would often include a cost-benefit analysis. Step number 4, do it. Well, this presumes that the cost of the cure is less than the cost of the disease. 1, 2, 3, 4. What could be easier? Well, if it were that easy, we would have far fewer, if any, unsolved problems to work on. So obviously, it is not that easy. But why not? The problem with all recipe-based problem-solving techniques is that they are incomplete. Woefully incomplete. They assume that you will fill in the prodigious-sized gaps between the lines of tersely written instruction. Troubleshooting a process problem requires time and tools. It also requires knowledge and experience. So, even if you had all the time in the world and all of the resources you could ask for, you would still need to know quite a bit about this process, as well as having a wide-ranging set of industrial experiences to draw from to work the problem efficiently. Troubleshooting a new problem is even more challenging. By new, we could mean new to the industry, or even just new to you. For example, it would do little good to know that an engineer in a competing company already figured out this problem if, for example, they did not publish the results or it otherwise became publicly known. What you will also need is to be quite organized and to be quite creative, and these traits are not necessarily common and are almost never taught. Also, you will need a big toolbox. A really big toolbox. A really humongously big toolbox. Just as a screwdriver and a set of wrenches will not allow you to do many repairs, so too is a single problem-solving methodology, even when there are several options within it. What sets this course apart is that it offers dozens of problem-solving methods and tools to choose from, including perhaps your favorites, such as Kepner-Trago, Six Sigma, and other formal methods. To this, we will add many, many others that may be faster or surer in some situations. In this course, we will try and make use of the widest variety of data sources, and that includes analytical, experimental, and observational. We will also include a source that is not commonly considered, and that is intuition. Well, we would not rely solely on intuition, no more than we would rely solely on analytical models, no matter how well pedigreed. It would be short-sighted to not also acknowledge intuition. However, like all tools, it has many pluses and minuses, and is seldom sufficient to finish any troubleshooting task in itself. The best critical thinkers seek to use the widest set of information sources to check any working theory. If we are good, and if we're lucky, all four sources will be in agreement on major points. If not, we have more work to do and/or more uncertainty in the problem-solving process. The real world is much more brutal than the simple methods you may have been likely taught. For example, in the classroom, there is only one right answer. However, in the real world, there may be 2 or 3 or 6 or even 0 right answers. In the classroom, you might have been taught 1 or 2 ways of approaching a problem. In this course, we will teach dozens. In the classroom, we have a couple of variables, while in the real world, we may have a couple of thousand variables. In the real world, the data is likely incomplete and often incorrect. The worst of it is that the real world does not really reward a good effort, only good results. Since bad results are so costly in industry, you must absolutely check your work whenever possible. Your career and your company's health depend on it. There are many pitfalls between us and a possible solution to the problem we've been given to work on. We have already mentioned not having enough time or money or the experience. Yet there are so many others that we will devote an entire section later in this course on how you might get stuck. The earlier we can see a potential pitfall, the more likely it is that you can steer around it. This segment is getting longer than I would like, but before we let you go, I want to share 2 interrelated ideas that underlie much of this course. The first is the dangers of having but a single idea, especially at the outset of problem solving, or the fallacy of a single right answer. As we see in this figure, there are 6 right answers, right? Any of the figures could be different, or none can be different, or all could be different. However, this does not consider combinations. For example, 2 of the figures are composed of only 2 segments, while the others are composed of 1 or 3 segments. We could make arguments for the rightness of scores of such working theories, and they would all be equally right. In the previous example, none of us could keep track of all of these ideas, much less to consider them equally. Indeed, we have trouble with keeping only two things in mind without latching onto one of them. Consider this figure. Which face is in front and which is in back? Here, there are two correct answers. However, most of us have trouble switching between the two fluidly. Our minds try to latch on to one view, and switching to the other requires a lot of effort. This, my friends, is one of the challenges of problem solving. That is, not to commit until the data or some other circumstances force you to take a stand. However, our boss or our customer will not wait forever. Find out in the next segments how to make this process as fast and reliable as possible. Thank you so very much for joining me in this introduction to industrial problem solving. I hope I have made the case that this course is unique and is worth your time. It is a summary of what I have learned by reading thousands of pages of problem-solving books and working in 1,000 plants. I have also learned from others what worked well and what didn't always work so well. In the next segment, we will begin the problem-solving process by defining the problem. In some ways, this is the most critical step and is the one that is often done the most poorly. Stay tuned and see why.